So the first presenter is Quoc. Have I
Yeah,
pronounced it correct? So yeah, your time starts now, 4:35 to 4:55 p.m. Yeah, please
all
go
right,
ahead.
all right. So today, I'm gonna like presentation my capstone, like the real explainable version 2 that using like the original paper that version 1. So on this version 2, so I use like the more like the Llama 311 model and the embedded model for the to increase the advanced research discovery. And let's see. So that my agenda today from the motivation, problem statement, and until the some key reference and Q&A. And for the motivation, so I want to build this one because so the researcher gonna waste a lot of time on whenever they do like manually filtering for the result, for researching the result, and then some AI, so they need to consider the AI answer is like real or hallucination. And then my newest version like 2.1 like gonna target on both of this. And the next one, so I want to build it because of the version they combine some high precision retrieval with better key phrase, better explanation, and we gonna have some model that can help like the non-AI user can understand the outputs of the model more than the black box than the original version. And for the problem statement, so we got a lot of like LLM model out there. So I want to constructively to use the best model to provide a just and reliable to avoid a hallucination and inconsistent accuracy. And for the original paper, so they use the doc to vet for embedded model with just 100 dimensional vector. So I shape it to better dimensional model with like 768 dimensional to increase more power to capture the semantic structure of the context. I also train the complexity of the model from linear, which it can like increase better for capturing the dataset more than the topic rank in the reverse model. So they use the especially it's gonna be brush the model while you're working with that. And for the background, so the original, so they get the good output for the result, but it still have some black box for that. And I want to build this model to close the transparent gap and remove the black box so that everybody can understand why the model choose this article more than just the random outputs. And for the related work and the synthesis metric, so I just say like so the Rocchio algorithm, so it's like let the user can interact with the model by giving them the model the feedback that they think like the article that related to the document. And then with this model, so I use the E file uh to make the model capture more semantic with the user feedback to re-rank the document to give them the best top 10 article. And for the approach, so I've replaced all the original methods like topic rank, natural language toolkits, the doc to vet by integrate the newest model, the 3.1 Llama with the intro to give the better objective summarization, better context summarization, and to reduce the human readable justification. I also like I'm extend the Rocchio algorithm, which is like providing the user feedback on the model to be ranking the document better to get the output of document like with more semantic and more relevant to the user query. And that's on my feature list. So I got the 311 model for the attractive summarization with the top three semantic relevant keyword, embedded model with more dimensional to give like more semantic retrieval, and the knowledge graph to accelerate the article discovery. And that I got the solution architect. The U on the left side is the U is my newest design compared to the right side for the original one. And the implementation. So I would say like so when user they give the query, all of the document gonna be embedding with the 768 dimensional vector space to give you the top 20 article with the key phrase, summarize, and context. And after that, you're gonna have the knowledge graph to connect your query with the related keyword and the related document. And after user select they submit the 3 relevant feedback for the article that they think that relevant to their query. So they submit the feedback, and the model will extend the Rocchio algorithm with the embedded model and the context matching to re-rank in the document to give you only top 10 article, which is the best for you. And the data collection, so I use the open research data set. The core is called like core 19, so it have like 136 100,000 rows, which have like 15 dynamic related subtopic, and I only select like 5,000 to test the model to work well. And if the model working well, I gonna make the full data set, because so whenever you training the full data set, it's gonna took you around like more than 100 hours to do it, and it will cost a lot of like CPU to do it. And this is the image for the metric. So we got like the top 4 metric, and we got the Llama is like doing better than the previous one with the map. It's like how fast the model get the right paper. The MRR is like, let's see, oh I forgot that. So the MRR is like the first 10 document is good or not, and the resistance 10 is the P10 is like on the top 10 article, the how many article it relate to your query. And the last one, the NDCG 10 is like the top 10 article is from 1 to 3 article, or it needs to go to like from 1 to 10 to find the top best article. And we got the data visualization with like the Llama get 43 query, like 86% better than the last model, like model T5. And we got like the knowledge graph, so that the thing I mentioned, like if you get the user keyword at the orange, and the purple one is like the article document that related to your keyword, and the green node is like the key phrase that related to your user query and to the document reference. And I got the finding. It's very cool about LIME and SHAP. So to explain like how many the context of the for each word it contribute to the relevant or irrelevant to the document, and the shape it will display like how each key phrase contribute to get the impact to the model, not just like randomly. And we got the conclusion like with the Llama 311, so this better for enhance the retrieval with reasoning, and with the implement of LIME and SHAP, let everyone can understand why the output is like relevant more than just the black box. And I just got the recommendation like so this model it can target on the biomedical review that demon the high retrieval transparent along the pool accuracy. And I think so that model can have a lot of in the research to help students and professors to do the research faster while they're looking the best article for them. And my future work is like, I'm gonna do like the eye tracking to check like where the user click the mouse to calculate the document that they must pay attention to that. And then they're gonna scale up from 5,000 record sample to full data set like 100,000 data sets and reduce the latency for that. And that my all annotated biography, and that's it. And I have a question. You can have any question about that?
Can I ask a question? So you're working on the Cord 19 data set.
Uh-huh.
So it is focusing on the eye movement. Can you tell what are the efficiencies you have achieved using Llama?
Can you say one more time? So yes.
You have done a
Yeah.
great job. Yeah.
Because
So
so yeah, go ahead.
so Cord 19 is COVID-19 data set itself. So they have used it only for the eye recognition movement.
Oh, I think it should only work for the only one type data set, like just the core 19 only. So
Okay.
when you search on the other query outside of this data set, it will not show anything.
Only about the eye metadata. Okay.
Yeah.
So you have done the uh, labeling manually or automated it, or it is already labeled in the data set itself.
Yeah.
Okay.
And my plans is to make like it can work well on the like Google Scholar, like for everyone can use it. Because I just try to test the model working well with the IR datasets, and then I can scrap the model. I can scrap all the dataset from the Google Scholar to make it work.
Okay. Nice. Uh,
And do we need to have a demo, right? No.
yeah, yeah. You can go ahead for the demo.
All right. Let's see. All right. Give me seconds.
Does anybody else have questions, or professor also can ask questions now? So you're going to have 5 more minutes for your
All right.
demo.
All right. For my demo, so it's like that. And whenever you shot like a virus or something, so first thing it will show you the node graph so that the user query, the related document, and the keyword that related to each document. Whenever you click on this one, uh, click on this one, it will highlight the relevant document, and you can view the context so to explain why this is relevant with the three top keyword. And we got LIME and SHAP to explain like the score. So we got the baseline right here. So if the score after H3 work contribute to get the score more than the baseline, so this means the model and this article is working well with the user query. And after that, so you just click this relevant. So we got this one. So we can let's see, can try with this one relevant, and the last one. Let's see. All right, let's see. You got three relevant, so you can submit to one more. There we go. You can submit the feedback. It will calculate, it will be ranking the document based on the cosine similarity to give you only top 10 articles that related to your query right here. And you still have another graph, but it's like just the top keyword and the related article right here. And then you still have the LIME and SHAP to explain why this relevant to your topic. All right.
This is Hannah. This is out of my scope, out of my knowledge. So my question is, how did you put, my understanding of this research is you put the samples together and depending on your keyword search grabs the samples relevant to your keyword. Is that correct?
Uh-huh.
Okay. How did you choose your sample, I guess is my question.
So so the sample is like I need to train on a Google Colab to get all of to get my data set working well on the back end first. So I need to train like to get like the top 3 keywords, the relevant explanation first. And after the user search the query, so it will calculate on the back end with use like the cosine similarity score to get like the one with the highest score. So whenever they get like 20 highest score, they will pop up to the user output. So that's what you see. And then when the user they select three more relevant topic that they want and they submit the feedback, the model will re-ranking the document again with your 3 submit feedback, and they will calculate the cosine similarity to give you only top 10. So the top 10 will be the best document that relevant to your query. That's how the system works.
So we can use this for our research projects too.
Yeah, so that
Yeah.
my plan is like to scrap to get all of the Google Scholar like article to grab all of them, and then to let the user let the student or professor like find the document faster.
Thank you.
Yeah.
I have one question. Have you made it available for public, or have you hosted it on cloud services or anything?
Yes, I don't know. I thought I need to public on cloud for this project. But the problem is like when you're working with a lot of data sets, so when you're training, it will cost a lot like GPU. So I don't have enough of GPU. So for this sample, like 5,000, it took me like 6 hours to train the process to get the sample relevant. So
If I may add to what Vuong said, hey, this is Shiva. I'm the advisor for this. The data that Vuong has used is pretty much, limited data. So, this is related to clinical information. So it would be in our best interest not to have it published for, everybody else to use, because you're just inviting lawsuits at this point of time, because, it needs to be curated. It's got to be validated. It's got to be against an extensive array of documentation, corpus of data. I don't think we're there yet. It'll take some time to get there. And again, you'll have to go through a lot of approvals, federal approvals to even get that going. Back to you.
If anybody else is not having any more questions, we can go for the next presenter. As an interest of time, like Professor, you're having any questions for Dang?
I did have a lot of questions earlier on because I was like, taking the entire class through for the last 10 weeks. So I don't want to surface any further questions for now.
Okay. So okay, we can go for the next presenter, Michelle Terrell Hagen.
Right.
I think
Thank
I
you, Vuong.
pronounced it. Yeah, thank
All right.
you, Dang.
All right. Thank you guys. All right. I can start sharing and waiting for the next one.
Uh, I think Hannah has joined, so I think we can go ahead with Hannah because Michelle has not joined yet.